My name is Tan Jun Hong. Now I would like to talk about the phase 1. The main goal of this phase is to establish a secure visual private cloud VPCs and deploy a standalone web server to host the applications. So for the first, we need to go to the VPC. Now we need to create the VPC. For the first is resource to create. We need to choose VPC and more. This is optional. Automatically create the required subnet, route table, and internet gateway and link them together. So for the next of the is number of available zones. AZs we choose 1 because since there is only one web server. So for the next we like to do is public and private subnet in zone A. So from this, the public subnet CIDR block, we will select it to 10.0.0.0/24 and the private subnet CIDR block, we will type in 10.0.1.0/24. Okay, so now we have complete the public and private subnet in zone A. So next we would like to do is the net gateway. So from the net gateway, to manually place a net gateway in a specified public subnet of our zones, so we choose zoner. So next for the net gateway, we will choose in one available zones, which is reduced cost and simplified configurations. So for the VPC endpoints, we will choose none because the VPC endpoints are not required for our projects. When we done, we can click the create VPCs. Now the VPC is created successful and we can view the VPCs. It is available and it is correctly. So now we need to do is web security group configurations. So from this, we need to go to the EC2 and then go to the security groups. We need to create a security groups. The security group's name is web security groups. And then for the description is enable HTTP access. So for the VPC, we choose that we create. For the inbound rules, are configured to allow HTTP, active for web browsers access, and SSH22 for remote terminal administrations from any source IP. So we choose all zeros, anywhere source IP, and then create the security groups. So now the security groups is created successfully. The next I would like to create is the instance. So we need to launch instance. For the instance name is web server. For the application and OS image, we select the Amazon Linux and the AMI is default. So for the next I would like to choose is the instance type. We will choose T2.micro. This is because the T2.micro is cheaper. For the next is the key pair. So for the key pair, we choose void key is to use to access the command link of the web server. So for the next I would like to edit is network setting. For the network setting, we just selected the custom network created earlier. And for the subnet is allow external user to load the website, so we select the public. And then for the auto assign public IP, we select is assign an IP address to access the instance, so we select the enables. For the firewalls is managed by the web security groups, so we need to select existing security groups and then choose the just now we created. So for the network setting is done. So for the last part is advanced details. We need to add in the user's data. So this is the user's data. From this user's data is have MySQL commands and the PHP files. So we have add in and then we just launch the instance. Okay, so now for the instance is all successful, running and check pass. So we can click and then copy paste the IPv4 address, and then we need to go to the new site and then paste the IPv4 address, enter. So now we are going our website. This is the home page of the student management systems. So we can click the view student list to go to the student list page. So this is the student list page. It displays a list of the students, including the student names, student ID, and the system allows the users to add, edit, delete student data. So for the first, I would like to try to add students. So we click the add new students. From this page, we need to key in the student names and the student IDs. So now we have key in the student name and the student ID, and then we click save. The new record is added to the list, and the message student add successful is displayed to confirm the action. So for the next I would like to talk is the edit students. So we click the edit student button, edit buttons. We can go to the edit student page. So we can update the details and click updates. So we change this to Lin, and then we click the updates, and it will save the change and trigger a message that is student update successfully. Next is student deletion functions. When we click to the deletions buttons next to the specify student record parliamentary, remove the entry from the list. The message successful, student deleted successful is displayed to confirm the actions. So that's all for my part.
Good day, sir. My name is Yongchen. In phase 2, our main goal is to migrate the student data storage from the local web server to a dedicated Amazon RDS database. This architecture improves security and reliability. So we need to go to the VPC, subnet, create subnet. First, we need to create the secondary private subnet for our multi-agent setup. We name it with project subnet private 2. Increasing the available tool with the CIDR probe. This will host our standard database. Create subnet. After creating the subnet, we need to update the router table association. Both private subnet are linked to the same router table to ensure the secondary database should be maintain connectivity. Next, we will create a database subnet group to define our RDS instance can run. So we click the create subnet group. For the name, we name it database subnet group. And the description in DB subnet group. Select our project VPC. Also the available tool 1A and 1B. And also the group private. Add the private subnet for both available Zone A and Zone B. Ensure the database is isolated with secure network boundaries. Now we have to configure the firewall rules by creating a database security group. Go to the VPC, security group, create security group. We name it with database security group. And permit access from web security group is the description. Select our project VPC. For the inbound route, we allow my SQL traffic on port 3306. We will restrict and we We restrict the source to the web security group. This allows only our web server to communicate with the database. So we create the security group. Now let's create the database. To create database, for the database creation method, we choose full configuration, allow for custom networking and multi-agent setup. We choose my SQL engine and the dev test template because it's optimization setting for development to minimize cost while maintaining essential features. For availability and durability, we choose multi-agent DB instant development 2 instances. We choose the self-managed and the master password we enter project password. This password used to connect the web server to the RDS database. For the instant configuration, we choose clustable classes. For the storage, with 20 GB, the GP3 is the latest, most affordable high-speed drive, using the minimum 20 GB size to keep project costs as low as possible. We choose the project VPC. And we remove the default, and choosing the database security. For the monitoring, we uncheck the enable enhanced monitoring. Standard monitoring is enough for this project. Turning off enhanced feature avoids extra cost. Now we go to the additional configuration. We uncheck the backup because save on storage cost and avoid slowing down the database during backup tasks. Also uncheck the encryption. Keep the setup simple and key and easy to manage for the project. After that, we create database. Now we will wait for the endpoint to be generated.
2,000 years later.
So we can copy the endpoint. The endpoint URL and add into the user data script to allow the web server to connect the database automatically. Now we will launch the new web server. Launch instance. So name with web server 1 RDS. We just reuse the phase 1 setup, updating only the user data script was changed to the link the web server to the new RDS database. Modify the endpoint, server name, password, and database name were already configured for the connection. So for the user data, we just copy paste and launch the instance. So we try to copy the public IP and open in my browser. So we can get a view student list. So the website loader with the empty list confirm the connection is successful. The list is empty because the data SQL data entry commands were removed from the phase 2 script. So before we using the website, we must create a table in our new database. We connect to the web server using Easy Instant Connect. Paste our endpoint. Enter the password. So we can execute the SQL command to create the user table. I just copy paste. So this table is essential for storing student record in the RDS system. Let me open again. Now we try to add a new student record. So success, the student data now is being stored securely in the RDS database. Now we go back and try to perform a manual backup of our RDS database. So we need to exit. Sorry. So finally, the MySQL DOMP command was used to explore the database. By connecting with the endpoint and admin credential, all data and structure will switch into a local file named dump.sql. So that's all about our phase 2. Thank you.
Good afternoon, sir. My name is Chang Jun Yu. Now I was starting for the project phase 3. The goal of phase 3 is to use a load balancer as a single stable entry point for the website. This provides a permanent link for users and automatically send traffic to healthy servers across different zones to improve stability. Now I will create a new subnet, public subnet. Project subnet public 2 and the available zone 1B. Is to host an additional web server. Let's connect both subnets to the internet gateway, allowing web server in both zones to communicate with the internet and the load balancer. Let's create a AMI. Create web server AMI as a complete template of the first server since it already contains the OS, Apache, and PHP file. New server launch from this image are ready instantly without needing a user data script. Now let us wait the AMI. This AMI status become available. Now this web server AMI status is become available. Now let us create a new instance. An instance was launched by naming it web server 2 LDX. Selecting my image and choosing web server AMI image. Web server AMI. Launch account of the web server 1 LDX in subnet 2 zombie. All settings will keep the same and no user data was needed because AMI already had everything installed. Waiting for web server 2 LDX, the status become pending and the status check is complete. Now this web server 2 LDX is become running and status check is complete. Now create a target group. Target group we choose instance because set EC2 instance as the destination for all income web traffic. And the target group name, project group, protocol as AD because route web traffic to the server using HTTP and port 80. The VPC, project VPC, has linked the target group to project VPC so the load balancer can find the web server. Next, getting a load balancer. To choose the application load balancer because selected ALB because it's optimized for HTTP and HTTPS traffics. Load balancer name project ELB. The VPC project VPC. Place the load balancer in the same network as the server and database. For the available job, select both US S1A and 1B. The load balancer to load traffic to target in both locations. Security group, West security. Security group, we choose West security group for manage all income traffic to the load balancer, listener and routing HTTP edit and routing action forward to the target group and specified project group. It will instantly sending web requests to the server in the project group. Next, web server 1 and web server 2 LDS will register as target within the project group target group. Now let us wait until health status become healthy. Now the healthy status for both web server 1 LDS and web server 2 LDS within project group is showing as healthy. This confirms that both instances are ready to receive and process user traffic. Now let us access accessible ELB DNS. The load balancer provides a DNS link to access the website. Now the website loads successfully while the load balancer DNS confirming that the auto-scaling group launched healthy server and the load balancer is routing traffic correctly. And that's all for my part. Thank you.
Hi sir, my name is Yongjin. Now I will continue with the phase 4. The goal of phase 4 is to implement AWS auto-scaling to dynamically adjust the server capacity based on demand, optimizing both performance and cost. First, go to the EC2 and launch template. And name it as project config. And choosing an auto-scaling guidance to ensure the template is fully compatible with auto-scaling, preventing conversion error. And choosing my AMI. And choosing the existing web server AMI so the new server can automatically connect to the database without extra setup. And the instance type, choosing T2.micro because it is cheaper and sufficient for our flag. The key pair choosing Foki, we use to access the command line of the web server. And instance is managed by the web security group. And enable the auto assign public IP. This will allow the instance to connect to the internet gateway, ensuring they have the mobile internet access need for communication and update. And enable the detailed CloudWatch monitoring. This allows the system to detect and respond to traffic change every minute and create a launch template. Once we create a launch template, we go to create an auto-scaling group. And name the auto-scaling group project auto-scaling group. Select the template we just now create. And select project VPC in the public 1 and 2. And it will automatically distribute the instance across these two zones. And select attach to existing load balancers. And set the load balancer we create before. The load balancers will automatically detect the new server and start extending its traffic immediately. For the group size, set the desired capacity to 2. It will always maintain 2 active servers, and minimum also set to 2, so always has at least 2 healthy instances running. And the maximum set to 6 to allow the system to grow up to 6 servers during the peak traffic period. And auto scaling set the target traffic scaling policy, and name it as project scaling policy. And set the target value to 60. The system will create a new instance automatically whenever CPU usage hit to 60%. And enable group metric collection within CloudWatch to allow us to use the CloudWatch to check traffic and monitor server health. And add a tag. Every time the auto scaling group launches a new instance, it will automatically tag it with the name project instance. Create the auto scaling group. The auto scaling group had now successfully launched 2 new servers named project instance and the auto scaling group update the target automatically, but need to deregister the previous configured web server to ensure the traffic is routed to the project instance. And now the project instance shows health. This confirms that the instance is ready to receive and proceed the user traffic from the load balancers. Now we try to visit the website using a load balancer provider link. The website loads successfully via the DNS link, confirming that the auto scaling group runs the healthy servers and the load balancers is routing traffic correctly. And also can use the CloudWatch to monitor the traffic and perform. The 60% CPU threshold is set. Status is showing OK, confirming the system is running within a safe limit. And that's all. Thank you.